We want to talk about how to do something as complex as a fraud detection in a set of transactional records with just using SQL. And I said that this is me, a rather new picture with a little shorter hair at Oracle, but this is probably where you will find me and when you look at the internet. So I'm a soccer fanatic. I'm also a developer, dealing mostly with the database code on that side, and I'm happily into friends and family and get together whenever I have a chance. And Gerald is smiling here because we were out last night. Finding patterns in your data. When you look into all the languages that are actually providing something like pattern recognition, there's quite a number of languages out there. And when I was looking that up as a preparation for this session, I was actually a bit disappointed that I didn't see SQL in this list because we have to fix it. SQL has indeed pattern recognition technologies. Row pattern technologies, which is there, I think, since the version 9, which is actually the capability to find a pattern within a string, where you would find, for example, whether someone has written my name with one N or two N's, or whether he has spelled my name with one or two R's, these kind of pattern recognitions within a string. What is kind of new in terms of the capabilities in the database, and you see I put new in quotes because new in that sense means since 2013, is the capability not only to detect pattern within a string, but it's a technology that detects patterns in a stream of events, where the stream of events is actually a stream of rows or transactional data. Mostly transactional data when I look at the customers that we're working with that are using this technology. Time is playing very often a role here, and when I map this to the pattern recognition in the stream of events, it is analysis of patterns, of attributes, of states across a set of rows. So it's not about finding, okay, is the name Herman written with one or two N's within a string, but it is about finding a pattern. How did the state of specific things change over time or over the order of my stream of events? It's an inter-row pattern recognition, which is from a technology perspective very exciting and helps us solving very complex problems. So when we in development approached this and we're looking into building this, we basically had a simple goal. We want to provide native capabilities within SQL that adhere and takes over some of the technologies and language constructs that were known before and provide a framework to really make the usage of this new functionality very intuitive and simple. And as you will see later, right, if I can do it, everybody of you can do it. Right? There's a reason why I ended up in product management and didn't stay on the hardcore development side. So what we did is we introduced a new SQL language construct called match recognize, which is since 2 weeks, 3 weeks, Gerald? Roughly 2 or 3 weeks now officially part of the brand new ANSI SQL standard, the ANSI SQL 2016. It only took us about 6 years to get it in. So it's standard, and when I look at the intuitive process, we were looking into how do I approach to find such a pattern. And there's actually 3 simple things, right? First of all, I have to define somehow what is my stream of events. How do I distinguish all this data that is coming from to identify what belongs into one stream bucket or not? Is it that the stream of events is, as we will see when we get into the fraud detection, that I just want to see the transactions that happen on a specific account, on a specific user ID, or is it a specific product line, a specific region where I want to track how the state is changing, or a specific machine where the temperature, we have this with one of our manufacturing customers in the iron business, where the temperature is changing on a per machine base. So the stream of events in that case is defined as change of temperature of a machine. Then it's obviously, you have to define the pattern. What am I looking for? What is the pattern that I'm seeing? Is the color changing from red to green to yellow, and does it happen 5 times in a row before it identifies the pattern that I'm looking after? And last but not least, well, if I found a pattern, what information do I want to collect? Right? Do I want to know every detailed state that happened within the patterns, or do I just want to have a summary? When did the pattern start? When did it end? Like a stock price, right? You want to track when a stock price shows a V shape or a W shape. Am I then interested in when the shape started and when it ended, or do I want to have each and every individual data point within the pattern? So these are basically the logical, intuitive concepts that we have to think about before we actually can translate this into what I always call baby English, also known as SQL. Come on. Now we have solved the hardware problems. Now we're going over to software problems. Come on. Next slide, please. Okay, my machine has decided to take a timeout. But we are now looking into exactly that with a simple fraud case, and that is actually coming out of reality. I will show you the code running live later on using our live SQL framework, which gives you the capability to actually write SQL against an Oracle 12.2 database. I have also the backup. I have it installed in my Docker file here on the system, but for you, we will go through that in live SQL, and everybody of you can actually start playing with it later on. And we simplified this. This is a real use case. We simplified it a little bit to make it easier to follow the concepts and the paradigms of how the pattern matching works by saying, okay, suspicious money transfer, money laundering, in our simple example is defined by finding 3 small transactions. That is, small means less than $2,000 within 30 days. It's kind of to probe whether this new account, raises some flags somewhere in the bank or the security or the audit. And when this is fine, there's a big transaction, one big transaction following within 10 days after the last small transaction, and then run, Forest, run. So this is the pattern that we're looking for, and what we want to see reported from our analysis is we want to see when did the pattern start, when did the pattern end, and what was the amount of the large transfer. And we're now going to step through a simple example using 10 records or so. The data, in that case, comes from a transactional log in a JSON format, which is a format that the database natively speaks by its built-in schema on read capability. So what we're going to do is this. We start off with this JSON log that we have in the database, and then we just basically put the structure on it with SQL constructs, and then we work against it as if it was a table. So this is the sample data set that we're having, and if I give you enough time, you will actually spot that pattern in that case and wouldn't even need SQL. But it's a very good thing, to actually demonstrate it. So I also limited to only one account. You see my friend John here. There's 3 small transactions between the 2nd of January and the 20th of January, and then he does the big transfer of $1 million. I wish I would have that on my bank account. Transfers it on the 27th, which is within the 10 days of the last small transfer. Okay. I said at the beginning we have a brand new SQL language construct, which is the match recognize, which obviously needs some input to define what we are looking for. And we're now looking at these 3 simple concepts that I said before. The first thing is, okay, how do I define the stream of records that represents the events that I'm focusing on? And in that case, it's pretty simple. For everybody who has an account in this transactional log, I want to order all the transactions that have happened by time, which is expressed with the partition by user ID, order by, time ID. And you see partition by is a clause that is in analytical SQL since version 8i in the analytical function. So that's conceptually we try to reuse and adopt technologies that our user are already familiar with. So now after we have defined our stream of events, the next thing is we have to define our pattern, right? And pattern are expressed using POSIX compliant regex regular expressions. It's easier than the short. Where you just give the pattern a variable name. In that case, I picked X. You know, I'm a lazy guy. I could have also called it small transactions, but you will see when you start typing, small transactions becomes a very long word at some point in time. So X is a little easier. We said also X with the syntax 3, open-ended, which is the regular expression for at least 3 occurrences or as many as they are. Within our pattern, we said we want to have at least 3 of the small accounts, small transfers, plus 1 big transfer, which in that case became, you know, you could have probably guessed that, the variable name Y. That's the pattern that we're looking for. Very simple, very straightforward. The next step is obviously, and you see it, this is just a sample syntax of what you have available here. You know, you can find exactly 1 event, you can find 1 or many events, 0 or more matches with the star, and so forth. We were using the bracket, open bracket n, comma, end bracket for n or more matches in that case. The next step is, how do I define these variables, these events within the data set that I'm having? And what you're seeing here is pretty straightforward SQL, where you say, okay, the variable x, that means the small transfer is defined by an amount less than $2,000. And within the series of the events of x, the fact that the last of this event is less than 30 days away from the first event. That's all you're doing, right? So if you had the 3 transactions that we saw before and the third transaction would be a month after the second, it wouldn't qualify for that pattern. And in the same style, Y is simply defined as the amount larger or equal than 1 million. And you see here we have a cross-variable reference that the time when this occurs is no further away than 10 days from the last occurrence from X. Because we can have other transactions within the pattern, right? So our friend could do other things in the meantime. So this is how I define the pattern and how I find the events within the pattern that I'm looking after. Now, coming to what do I want to see reported? This is a new clause within the SQL statement, which is called measures, where I said in that case I want to see the first of the X events, the small transfer, and I want to see the last of the Y events, the last transfer. The information within the measures could be specific data points, like you have seen it here, or it could be aggregations or cumulative aggregations, final aggregations, and so forth. So those are the 3 measures, and what you're seeing here is what's implicitly already said is that I'm not, by the nature of the measures, that I'm not interested in every single data point here, right? So I'm just interested in basically the summary of the pattern of what has happened. So when I get 100 little transactions and 1 big one, I will get back 1 row per match. If I have 3, the minimum criteria, and 1 large, I will get 1 row back. So this is what I'm saying here in this syntax, and this is the whole statement that you need to do the fraud detection. Just to give you an idea, and we will actually do some of these other things, you can also ask Oracle to give you back all the detailed information about the pattern, which would be the all rows per match, or something where you want to see not only the data records that have matched, but also the data records that have not matched. To see, for example, how many transactions did he between 2 events of this suspicious pattern, right? So there's information in there. You also see normally people starting off with unmatched row just from a debugging perspective, and we will briefly look into that as well, because patterns can become very complicated, and it's very easy to oversee specific edge cases or corner cases. So having the capability of of doing some kind of debugging with this functionality is very handy. What we will see when we run it live, we also have built-in measures that help you to analyze the system or to get even more information about it, which are namely identify which of the events a record falls into. Is it a small transfer or a large transfer, which is probably in that simple case easy to see, but there's more complicated patterns. And how many matches did I have in my data set? It's also powerful in a sense that when you found a pattern, you define where does the next analysis of the next pattern starts. You can think of if I'm looking for a W shape in well, let's say a stock price change, right? If I have 3 of the V's next to each other, so now it's my decision, is this one W and one V, or is it 2 overlapping W's, right? So you have to have the capability to say, where do I want to skip to if a pattern is satisfied, and where do I want to start the next investigation? Okay, and finally, you define what is the output. What we're seeing here is we use the aggregated version, the 1 row per match, meaning that at that point in time, I can only get basically the measures back and the information that I have in the partition by clause, because that's a unique value, right? So with the 1 row per match, we are losing the detailed information, and you would not see the initial data points for each individual record within the pattern. Okay. You probably have recognized me right away by my nice glasses. Let's now actually look on how that looks in the real world. So I'm here on live SQL, and I was just looking for match recognize, and we actually set it up specifically for the Oracle Code event. And that's a framework which gives you the capability to actually run live SQL. So a select star from emp would give me a 942 table of view does not exist. And if I were to go after the JSON transactions, and what you see here on the right-hand side is basically a written version of what I'm just telling you, probably in a better English. Let's now just create a table which basically only has 1 column, transaction, document, which is a CLOP. Can you see, is that big enough in the back? Perfect. We just create that, we copy it over, we create the table, and insert some of the dummy data. Okay, if I'm now going and just select from that table, JSON transactions, okay, you will see it's just a whole bunch of JSON documents. It's, from a database perspective, at that point in time, it's a LOP, right? You can put in whatever strings and whatever you want. Normally, in that case, actually, we restricted you a little bit because we have a check constraint where we say, okay, when data is inserted, we check that it is a valid JSON document. But apart, conceptually, a LOP normally can get whatever it wants, right? So if I'm now using the built-in capabilities for Oracle to look at the data in a structured form, basically the schema on read, which is defined by, okay, you start with the alias of the table, and then the column, and then basically the JSON value within the JSON document. You will see all of a sudden that the data is coming back in a structured form. So now I'm blaming the internet or the ball, one of them. Okay, should I start Docker? Okay, we can, okay, where am I? Okay, Docker stats. Okay, it would be up. Okay, just to have a fallback. Still coming back. See. Oh yeah, I'm wireless. That's fine, thank you. Okay, but we can start. We could start it here as well. Okay, let's do it. Okay, we inserted the data, as you can see. I have a fallback. We saw the JSON transaction, and this is how it would look like when you use the the built-in JSON capability now looks and smells and behaves like a table, returning just the attributes in the JSON document that you wanted to look at. Okay. You also saw what I did as the next thing is I'm just filtering the data. So you saw here in the initial file we have transfers, withdrawals, deposits, and so forth. The moment you transfer it into basically a relational form with that syntax, I can filter on it. And from a fraud detection, we are only interested in the transfers. So by adding the filter predicate on the event ID only being transfers, you see the data set that we had on the PowerPoint. And when I run the SQL, that is the statement that we showed you before. You see we have the partitioning by the user ID, order by time ID. We have the one row per match. We have our X and Y defined as you saw it on the slides, with the small transaction and the large transaction, where I needed at least 3 of them. And as a return, you get back, my friend John had a suspicious money activity starting on January 2nd. And the pattern ended on January 27th with a transfer of $1 million to a now unknown account at that point in time, right? Because we didn't get the data within the JSON information that was provided to us for analysis. This is the same statement where I modified it a little bit, starting with I want to have all rows with unmatched rows, meaning I'm getting now the detailed information across my whole data set. And what I also added is what I briefly mentioned on. I added the match number and the classifier to give me an understanding of where am I within my pattern. And you see here there was a transaction somewhere in September. Yeah, then my friend John didn't do anything until he got active again on January 2nd with a small transfer. And then it's basically an internal state machine what we're building here and stepping through. And as you can see on the 20th, we reached the critical point of 3 little transactions. At that point in time, we said, ooh, X is satisfied. We look at the next variable. In general, we are having greedy variables, so we would try to find more X's. But if we don't find an X anymore and we have satisfied the first part of the pattern, we say, oh, it's time to look for a Y. And as you can see on the 27th, we then have the large transaction. And what happens later on, smaller transactions, nothing. He stopped. That was probably the time he ran, or the time he was put in jail. You also see this is the detailed information of the record. And from a measures perspective, that is the information that we got back in the first go-round. The moment a pattern is found, the first time is set, right? The first time is fixed. It is the 2nd of January. And the moment you find the last transaction, the other 2 measures are satisfied. So these are the measures that we are looking at, right? So the first X, when I started my pattern, the last Y, basically when did the big transfer happen? And what was the amount of the Y? Because it only happens once. So you see the information plus the match number and the classifier, which part of the pattern does the data record belong to. You see that you have the whole information of how the data was analyzed by Oracle and how the pattern was found. Okay. So you have seen me monkeying around with some code. Now, as always in real life and as part of our job security, there's always new requirements coming up, right? So we have the same case here with our pattern matching, where we all of a sudden, the system that actually feeds us the information got improved. It also has the information about the target account in the information. And we're refining our fraud detection analysis example to a point where we say, okay, history evidence shows that it's fraudulent if the little transactions are just scattered around different accounts. And the total sum of the small transfers is less than 20K. So we get enriched data set, and we have a changed business requirement here for the data. And when we look at the new data set with the additional information of the transfers and the new requirement that is less than 20K, you will see that we find the pattern again. We have the 3 transfers from John to 3 different accounts. And the big transfer is still within the 10 days. So the pattern that we had before is satisfying our new requirement. So how does this look like in SQL? It's pretty simple. It's the same pattern that we looked before with additional conditions. So all we have to do is basically to address this new requirement is there's a new requirement to define a data record as X, as the small transaction. Now, within the context of the X itself, where we say, okay, so every time I'm doing the small transfer, it does not go to the same account as it went before, right? It's very easy to identify by self-referencing within the X to the previous account that the money was transferred for. And the other requirement was that whenever a large transaction happens, I'm cross-referencing the other variable saying, okay, the sum of all the X events is less than 20K. So this was all that is necessary to get that done. And let's now see that live. Let's see. Oh, it came back. Okay. Okay, do I still? Let me just quickly see whether that works. Just do the same way it was thinking. Okay, we had that. We had the all matches per record. Okay, the changing requirements. Let's now truncate the table that we used for the example before and insert the new additional JSON information. Okay, now the interesting thing is if I were to go back. So this is different data now, right? If I go back and run the original one, no, that's not the original analysis, guess what? It will still work because we don't care about the additional information in the JSON log. We don't make it a part of our schema in the statement that we had here before. So we have the full flexibility here by using this new kind of data processing. Okay. When we look at the new data, as you can guess, we have pretty much, it looks almost like the same as before, just with the transfer information now. And when we look at the enhanced business rule, as you can see here, we added the additional previous test and that the sum is not there. You will see, that the information is found. So from a pattern perspective, we have quickly adjusted and adopted a new environment. We could do the extraction of additional information, and what we're doing here is, it's a little bit of an edge case. What I'm doing here, you can actually refer to values within a pattern as well. So since we know in that case that we're getting three data records back, you see that we are kind of flattening the data with amount 1, transfer 1, amount 2, transfer 2, and a transfer 3. We get more information. And that is the point where you actually really can go wide. Let me just probably, I could change this to all rows per match. Should simply work. You see now you have the information, but that is the aggregate information, right? You say the first time, you see the transfer 1, transfer 2, and you see how it fills up. You could do let's just remove all of that. Remove this. Let's do here sum of the, I want to see the total SQ amount. Okay. I'm sure I'm making some mistakes in the syntax, but your friendly SQL will tell you in a second. Amount, okay. I moved all of those. So this is a live running database in the background where you can go and enjoy yourself. Amount, what do I have? The cumulative amount. And let's take the transfer ID net. That is that interesting. Let's see how I got it right. Oops, I got it right. You see now I added the cumulative information. And interestingly, you see I did a cumulative sum for x only. That means it stays the cumulative amount of x also for the last record, the y. If I were to say, okay, I want to see all the money that was moved, it's as simple as removing 2 characters, and you see that pops up the 1,003,700. And this is, when we look at it, what we can do in SQL using Oracle as a data processing engine. At that point, I do not even care about the data management, because that is something that we're looking the way of how the database or how the framework evolves. The database is only one part of the data store that can be accessed and processed by the database. So I could have actually run against this JSON log being stored in an external table, being stored in a NoSQL system, and just accessing it and using the SQL data processing framework for the analysis that I have shown you. So it's just the tip of the iceberg, because if you combine it with other capabilities that are within this framework, whether this is geospatial information that we're having in there, it might be interested in knowing, okay, where are the accounts where the money is going to, which may or may not be information that is readily available as an attribute within the JSON information. Maybe you only have geospatial code and you have to analyze which country is it in and so forth. You get a lot of power of what you can do with SQL as a development language for detecting these kind of problems. Or you don't want to know what we're doing with some of our customers that are close to our current location, where it's not necessarily the movement of money, but the movement of people. That there's a lot of analysis that actually happens in data that is collected in these kind of systems. We also, and that is actually a very old thing, we have Java code available that does exactly the same in MapReduce, what we're doing in SQL on a larger data set. And when you compare the lines of code that we had, pretty much what you've seen in this example versus what we have in Java and the runtime you're getting, it's kind of handy using SQL as a pre-built data processing engine with the built-in capabilities compared to actually write everything by yourself. So the summary, I think all the gray check marks, forget it. I think the big summary here is I would encourage all of you, to go back, use Live SQL, and just start playing with it to see how you can actually leverage this functionality to your advantage. And let me tell you, out of personal experience, right, it comes in very handy. The last problem that I solved is I wanted to understand how are extents within the database co-located, physically co-located, and which extents are basically adjacent to each other. What is the average size? And if you try to do that with a normal SQL, it becomes complicated. With pattern matching, it's basically you say, oh yeah, end block, end row ID address is start row ID address of the next record, sorted by row ID, done. So it's very simple. It comes very handy for a lot of use cases that you probably cannot even think of today. And I just encourage you to start playing with it. We've also, as you have seen on the slide before, a lot of tutorials and examples for specifically this powerful capability on Live SQL. And before I get into the Q&A, if you want to get more information besides playing with Live SQL, there's a lot of information on the homepage. We have an analytics blog where we talk specifically about that part of the functionality quite often, or just drop me a line. And at that point, there's no more live demo, unless you really want to. Absolutely. We will upload the slides. Back, forth, back, forth, back, forth. We will also upload the slides, and they will be all available for you guys as well.
Upload where?
That's a question for you, Gerald.
To the events page, so developer.com/code on the Washington DC in 3-4 days. Yes. You will see view content and all the presentations.
You will see the presentation with the monkeys. Okay. Everybody has taken a picture? I would have expected you guys to be more interested in seeing the monkey than that, but okay, I have probably a couple of minutes left for Q&A. No more handies up in the air. Okay, so now it doesn't proceed. Any questions from your side?
So,
okay.
Specifically, you said $1 million. Can you do some kind of average or?
Yes.
Because like specific amount, $1 million, maybe I can win $1 million or something like that.
Yeah, you can do it. And I had it actually in implicitly when we refined the requirement where we were going after the sum of the previous event, right? So or when I quickly typed it in, I used the cumulative amount. So you have both. You have final amounts, and you have cumulative information that you can use for the processing as well. It depends on where in the state of the analysis you are, right? So you cannot have the final sum of x before x is final, right? Or you cannot reference a variable that hasn't happened yet. So you could not say in the x refer to something that happens in the y. You would have to have a different event that happens before that you actually get that state within your pattern. But the short answer is yes. Oh, excuse me. Ladies first.
This for which release is available?
Oh, thank you. Since 12C release 1.
Release 1.
Yes.
Not a release 2.
It's also in release 2, yeah. We tend to not throw things away with new releases.
They can working for all data type besides JSON.
Yeah, absolutely.
Okay.
I just wanted to sneak in JSON capabilities in this presentation since we didn't get a specific slot for it, so I was sneaky here. But no, you don't need it, right? The moment when I use the JSON syntax, it looks and smells and behaves like a relational structure.
So joins, essentially a join off that X in that X expression where you might join to address or you might join to zip code looking for parallels in zip codes.
You would have to basically flatten the event record as the input where you saw when I had the upfront. Yes, you join upfront. You basically in that block you define what is my streams of record.
So it becomes a flat record right at
Yes. It's also, from a usability perspective, it's easier to write and to understand what you're doing.
Does the JSON function work on varchar2 or just clouds?
It works in varchar2 as well, but you have the limit of 32,000 characters, beginning with 12.1. Any further questions? None? If you remember any, there's a half question.
Geographic
Yes.
information is for exponential. If identify someone's address, it's suspected.
Yes, well, the geographic information that I had on the slide was, you can have geographic information that is flattened in a relational structure, like you said, an address, but it's also very often, that you want to go for distances or so. How far did someone travel, for example, and so forth. That's a use case where the spatial capabilities in the database come in handy, which can be expressed with functions and basically translated into something like distances or locations as well. This is what I was referring to, right? Obviously, whatever you have in a relational structure is there, but when I look at not so relational structures and geospatial information being one of them, since Oracle can transparently deal with this kind of information in SQL, you can transparently leverage it within this framework as well.
How this performance will look like?
blazingly fast. No, it's actually, that's a good question, and actually I could talk probably half an hour about that. It depends. It's fast. It's, you know,
How far the relationships are apart, right?
that is one of the things, how far the relationships are apart, and then it depends on whether you end up from a pattern definition, whether you have a finite state machine that you get to, or whether you have to traverse back 120,000 times in the state machine. Because that adds, you know, if you want to go for, so it's fast. It's faster than what capable Java developers could do with MapReduce. How about that? And if you find something that is not so fast, please let us know. And we tell you either we can make it faster or that we are in the state where we had to traverse back in the state machine, which isn't pretty, yes. And then it depends on how far you have to traverse back. Any further questions? If not, then I thank you for your attention, for coming here. And if you have anything else, drop me a note. Thank you.